Hi, so in this video, I will talk about the Poisson distribution. So if we are interested in the number of occurrence that take place in an interval, which is can be time or volume, then we use the Poisson distribution. Situation to be modeled by Poisson distribution are an experiment consists of counting the number of times in a certain event occurs. The probability that an event occurs is the same of each interval or the events occur independently. The variable x is the number of occurrence in the given interval, which is written as x po bracket mean. This lambda, the lambda is the mean, where lambda is the parameter of the Poisson distribution, and lambda is always positive and always and will not be zero. When the Poisson distribution is appropriated, the probability of exactly x occurs is given by this formula. As you can see, yeah, e power of negative lambda times lambda power of x with x factorial, where x can be 0, 1, 2, 3, 4 like this, which is the integer, positive integer. Sometimes we need to calculate the probability such as p x like this, p less x less than 10. In this case, we have to calculate p x equal to 0 plus p equals to 1 plus p equals to 2, still p x equals to 9. This procedure is you waste your time very much, so it's easier to use the Poisson distribution table. So here is the example of Poisson distribution. The table has many pages, so this is page 1. If x is the random variable following the Poisson distribution, then the expected mean of x will be lambda and the variance will also be lambda. So I prepare some question also. So we just go through a question. So question 1. Given x with PO, the parameter PO with lambdas equals to 6. So find A equals to x equal to 3, p equal x smaller than 2, and p equals 3, x larger than 3 and smaller equal to 5, the mean and the variance. For p x equal to 3, you can use this formula, e negative lambda x squared, or yeah, like this. I start this lambda equals 6. So the x equals to 3, so I just sub and I calculate it. I'll get 0.0892, or I use see the table, which is px larger equal to 3 minus px larger equal to 4. Let me find it if lambda equals to 6. Okay, lambda equal to 6. Okay, I got it. So px larger than 3, 0.9380. Okay, right? 0.9380 minus 0.8488. So I just take my calculator. So I will get 0.0892, which is same as the value. Yeah. So px smaller than 2, you can either use the formula, we sub this 0 and sub 1, sub 0, sub 1, and plus it all to get 0.0174, or I see the table by using 1 minus px larger than 2. Because this does not include 2, right? So I here I include these two and I minus away these two. So px equals to 2, so I will get 0.9826. So 1 minus 0.9826, I will get 0.0174. So same. So that is p x larger than 3, smaller equal to 5. So does not include 3 but include 5. So px equal to 4 plus px equal to 5. First, it's the same. I can use this formula. Sorry, e negative 6, 6, 4, 4 factorial plus e negative 6, 6 power of 5 by 5 factorial. Or I just use the second method. See, okay, it does not include 3, got include 5. So I use px equals to 4 minus px equal to 6. This got include 4 and include 5 but does not include this 6, and it does not include the 3. So I just see px equal to 4 minus px equal to 6. So 0.8488 minus 0.5543. 0.8488 minus 0.5543. So what I will get 0.2945. 0.2945. Yeah, it's same as the formula that I use it in. Okay, D and E is the find the mean and variance respectively. So the mean is equal to lambda, which is 6, and the variance also equals to lambda, which is 6. The number of traffic accidents that occur daily in a town can be modeled by a Poisson distribution with a mean 0.6. So find the probability that no accident occurs in a particular day. And find the probability that only one accident is reported in the period of 2 days. And C, determine the smallest integer k, that the probability that at least one accident happens at the period of k successive days as 0.99. I see it first. It say mean 0.6, which is the lambda equals to 0.6. So let x equals to the number of accidents occur in a day. So the lambda will be 0.6. So no accidents occurs in a particular day. So px equal to 0. It's just easy. Or just you use px larger equal to 1. So can find 6. Okay, 6. So 6 here. Minus 0.9975. 0.9975. A is I read wrong. It will be 6. Oh, okay. Let me rewrite. And I calculate it. So this I will get 1 minus 0.9975. So I will get 0.0025. If not mistaken. Just let me confirm it. 0.5488. Oh, sorry. Mean equals to 0.6. So I am correct. Sorry for my mistake. Okay, scared me. So let me go to 0.6. Let me find it. Sorry, it's 0.6. Got 0.4512. Sure. 0.4512. 1 minus 0.4512, so I will get, yeah, right, 0.5488. And B, let Y, okay, why I let Y? I cannot no longer use this X as my event, so because this 1 day become 2 day. So as sim, the lambda will be 2 times 0.6 equals to 1.2. So PO, this lambda will be 1.2, so just only one accident reported, so Y equals to 1. Or use the table, Px larger or equal to 2. So sub lambda 1.2, 1.2, and this x equal to 1, x equal to 1. So I'll get 0.3614. Okay, this k successive days, at least one accident happens in period of k successive days exceeds 0.99. So I don't know k is how many days, so I just let w with the number of accident occur in these successive days. So lambda will be 0.6k. So P, the number of accidents at least one times larger than 0.99. So 1 minus PW equals 0, also 0.99. So no accidents occur in these successive days will be less than 0.11. So is that right, wrong? Should be inequality. 0.68, 0.68. In this case, it's better for you to use this formula to do. So 0 factorial equals to 1. This power of 0 should be equal to 1. So you mean E power of negative 0.6k. So just move this lone. So k, this negative, you know this lone, this negative, you move this 0.6, you move this negative over the, change the side. So this smaller than will be changed sign to larger than. So k larger than 7.68. So the minimum k will be 8. So that's all for this Poisson distribution. So sorry for the mistake I did, and see you in the next video, and bye.